To start this tutorial, we'll hide the reference curves. We'll use them later. First, go to the Sub D tab and create a box. Type 0 and press Enter to set the starting point at the center. Next, type 20 for the length and press Enter. Then type 20 again for the width. Finally, set the thickness to 6 millimeters. Go to the bottom of the viewport and switch the display mode to shaded. If you hold Shift, it will apply the mode to all viewports. To center the object in all views, use the Pan, Zoom, and Rotate tool, and then click Zoom Extents All. Another common option is to type Artisan Center in the command bar with the object selected. This will center it on the axis. From the perspective view, we'll use the Split command to divide the object in two. Activate the command, enable the Edge Loop option in the command bar, then select the object and double-click the center edge. Press Enter to execute. Now the object is split in two. We'll delete the lower half to get a hollow element. To select the lower edge loop, enable the Edge filter in the Sub D tab. Double-click one of the lower edges to select the full loop. Using the gumball, move the edge loop down by -1 millimeter. Switch back to the 4-view layout for better control. Without deselecting the loop, use the Insert Edge command to add another loop. Select the lower edges again and use the gumball to scale them down, while holding Shift to scale proportionally. Reduce them until you get the curvature shown in the video. You can fine-tune the position of the newly added edges along the X-axis to smooth the outer curvature. Now let's create a surface to use as a reference. Go to the Curve tab and use the Duplicate Edge command to duplicate the two center edges. Before pressing Enter, you can change the layer to place the duplicated edges there. Next, use the Blend command to create a smooth curve between the two edges. Select the first edge, then the second one. Use the front view to edit the curve. Change continuity to tangency and adjust the handles to raise the curve approximately 2 grid squares above the lower part of the object. Click OK when satisfied. Create a point at the center of the curve. Use the Trim command to split the curve using the point. Ensure Sub-Object Selection is disabled so you can select the entire curve, trim the right side of the curve, and delete the point. Duplicate the edge curves of the reference surface as well. Next, go to the Surface tab and click on Rail Revolve. First, select the trimmed curve, then the edge. Lastly, click on the center point of the surface and then on the cut point of the curve. Now we have our bottom reference surface. Move it to a different layer so it displays in another color to avoid confusion. Now in the Diamonds tab, use the Automatic Pave command. Add the surface to the selector. For the stones, set the sizes to 1.6 and 2. Remove the 1.3 size since we won't use it for this model. Enable 4-way symmetry, turn on gem display, and click to add a start point. In the command bar, click Center and press Enter to begin the pave. Once the gems are processed, you can add more if necessary. Then go to the Prongs tab to configure the settings. Set the diameter to 0.75 millimeters, the height over girdle to 0.3 millimeters, the height under girdle to 0.5 millimeters, and the extension for manufacturing to 0.3 millimeters. Click Add automatically. Once all prongs are generated, you can manually add or remove prongs with the respective buttons. You can also change the size and add any additional ones where needed. I'll add some around the model's edges. I'll speed this part up since it's repetitive. Take your time to add as many prongs as needed. Now go to the Cutters tab, activate them, and leave the default settings. You can now confirm the command. Since we're creating a pendant and will later add a bail, Ungroup the cutters by selecting them and typing ungroup in the command bar. Delete the cutter located on the Y-axis, the green line in the viewport. Do the same with the gems. Select them, type ungroup, and delete the one on the Y-axis. Use the layer panel to reselect all the gems and type group, then do the same with the cutters. This helps organize multiple elements easily. Now hide the bottom part. Select the main model surface, and in the Sub-D tab, click on Offset. Set the thickness to 0.7 millimeters. Ensure solid is set to Yes, both sides is off, and optionally enable Delete Input. If the arrows point outward, but you want the offset to go inward, click Flip and press Enter. Now we have our solid. Since we didn't delete the original surface, we'll move it to another layer and hide it. In the Solid tab, use the Boolean difference command to subtract the prongs from the solid. Select the solid and press Enter, then select the cutters and press Enter. Now the solid is properly cut. Tip: for a more realistic render, select the gems and in the Diamonds tab, use the Gem Move command. Type 0.1 in the command bar to slightly lift all gems, creating a subtle shadow effect. Next, show the bottom surface and the curves. Hide the rest of the model for better focus. Move the curves inward and scale them to align the 2 points in the center. Use the Project command to project the curves onto the surface. Now we'll hide the green curves and work with the projected ones. If we want to select all the curves, we can type Cell CRV in the command bar. Projected curves usually have many control points, so we'll use the Fit command with a tolerance of 0.1 to simplify them. Now let's create a freeform curve to use as a profile. It doesn't need precise measurements. Select this last curve, go to the Accessories tab, and use the Profiles command. Without choosing any preset, manually add 2 profiles. Now we'll go to the Perspective view and edit the 2 profiles we created. For each one, set the type to Solid, the width to 0.7 millimeters, and the height to 0.6 millimeters. Do the same with the second profile. Change the mode to Solid, then adjust the width to 0.7 millimeters and the height to 0.6 millimeters. Once both profiles are edited, simply accept the command. The profile was created on a hidden layer, so reveal it. Now use Apply Style, select the profile, and apply it to one of the curves. If it doesn't align with the surface, we'll hide the rest of the model so we can work with the profiles more comfortably. Now we can see that the profile applied to the curve is positioned on the inner side of the surface. We'll edit it and assign the surface as a reference in the command selector. Now it adapts perfectly. Apply the profile to the rest of the curves. Now use the Apply Style command again, select the clone profile and apply it to the rest of the curves. To update them, select them all and click Edit. They'll automatically align to the surface. To finish the pattern, mirror the selected elements across the X-axis. To do this, select the elements, go to the Transform tab, click on the Mirror command, and in the command bar, select the X-axis. Then mirror the central ones across the Y-axis. I forgot to mirror one of the profiles, so I'll select them and perform a mirror along the Y-axis. Now the pattern is complete. We can hide both the surface and the reference profile to better appreciate our pattern. Reveal all elements and position them so they intersect slightly with the solid to ensure a strong connection. To do this, select the profiles and scale them using the gumball. Also, move them to make sure there is intersection at all corners. Remember to hold Shift to scale uniformly in all directions. Take your time to adjust it properly before moving on to the next step. Once the profiles are adjusted, our model is practically finished. Now let's add the bail. Go to the Accessories tab and use the Bail command. Use the gumball to place it from the top view. Then click Edit. For the top profile, choose Asset 012. Set the width to 1.9 millimeters, the height to 0.9 millimeters, top diameter to 2.60 millimeters, and the inner distance to 4.5 millimeters. Hide the O-ring to better see the changes. For the bottom profile, also choose Asset 012 and set the width to 0.9 millimeters, the height to 0.8 millimeters, and adjust the bottom slider. Now enable the O-ring again and set the thickness to 0.6 millimeters, the overlapping height to 1.5 millimeters, and the diameter to 1.8 millimeters. Confirm the command. Position the bail over the gem we removed. Now the model is fully finished. Now let's create a turntable render to showcase it on social media. Go to the File tab and open the Render and Animation panel. Using the Layer Manager, select the metals and apply the 18-karat yellow gold material by double-clicking it. We'll switch to rendered mode and apply a diamond material to the gems. For lighting, use two shapes. Then switch to Ray Traced mode to preview the final render. Now we'll go to the Environment panel to adjust the reflections. Change the 360-degree projection to two shapes. Try using a different floor color. Switch back to shaded mode and rotate the model 90 degrees. Adjust the view for the final render. You can select a resolution to view the guides. Everything within the lines will be rendered. Before rendering, switch back to rendered view and adjust the viewport position so that the background fits within the frame. Now, in the Render and Animation panel, change the render type to Turntable and under Video choose Custom. In my case, I want it to last 10 seconds at 30 frames per second. Remember, each frame is a photo, so 30 frames per second means 300 frames will be rendered. The total time depends on image quality and resolution. I'll set the quality to 20 and change the floor to basic ground. Set the resolution to 1200 by 1200 to get a square video. When clicking Render, you'll be asked to choose a folder where the frames will be saved. Once all frames are rendered, the video will be generated in .mp4 format. It won't be created until rendering is fully completed. At the bottom of the render window, you can see the time and number of passes. Here, 20 passes based on our chosen quality. In my case, each frame takes 1.42 seconds. I'll fast forward the process for the 300 frames. The final video will only be generated once all the renders are completed. In this case, 300 frames. The video will be automatically created in MP4 format, and all the rendered images will also be saved. Now we have our video ready to share on social media, so don't hesitate to share your results with us.